Hey, Graham here. We're going to start talking about section 5.7, our complex numbers. Hopefully from before you remember that I equals our square root of -1. That's going to be the big thing we're using all day today in our complex numbers, because how much more complex do you get than imaginary things? Alright, big stuff we're talking about. Conjugate. Taking your plus and your minus. It's kind of like our sum and difference thing we were doing before. X plus 2, x minus 2, or square root of something plus something equals the square root minus the same thing. Conjugate. We're going to use that later. Complex number always comes out looking like this, like 3 plus 4i. We've got our normal number in front and then something multiplied by your I on the back side. That's going to be our standard form that we're looking for answers when we're using our imaginary number. So first we're going to look at sum and difference. That just means adding and subtracting these things. If you treat your I the same way you would treat an x, like a 4x plus 2, the same way that we would treat those things as far as putting stuff together, that's what we're going to do here. So my 3 plus -6 gets written together here. Minus 5i plus minus 2i gets written together here. So 3 minus 6 is -3. -5i and minus 2i go together and make -7i. We don't put these together, just like we wouldn't put 3 minus 7x together. So we just deal with our I just like we would an x, as far as like terms type things go. So here our minus sign does the same thing, only now we've got a minus sign in both of these spots here. One way that I like writing that would be to take and sort of distribute that and change both of those signs and write them on top of each other. It gets you the exact same -1 minus 10i's as we do here. But it kind of just lines things up a little bit. Sometimes we mess up negative signs when we start doing crazy stuff like this. Alright, so example number 1. I'm going to go ahead and subtract these things. So I got 5 minus -6 plus 4i minus, now I'm going to write 1i, because it's just like with an x, what's really there, a 1x. Same thing with the I. What's really in front of the I, a 1. So 5 minus -6 is 5 plus 6 is 11. And 4i minus 1i is going to leave me with 3i. Alright, example number 2, you can go ahead and take care of that one yourself. It's just going to be adding, so it's a little bit easier. Hit pause and give it a try. Alright, product. We're going to multiply. And what's multiplication of two binomials if we're not using our box method? 3 times 5 is the 15. We get minus 30i here, plus 6i here. Now the weird thing is always going to happen down here in this bottom box. 2i times minus 6i. Well, we get the -12, but then I times I is going to be I squared. So that bottom box, we got -12 I squared. So that's our weird one that we're going to have to deal with. So this is just all our stuff written out from that box, our two middle terms that we're going to combine together and make this here. Now what's different is I squared. Just like yesterday, how we were kind of looking at square root of 3 times the square root of 3. The square roots cancel and make a 3. The same thing's going to happen here. Square root of -1 times the square root of -1 is going to make -1. Well, what's I? I is the square root of -1. So if we do I squared, it's just -1. And what that really does is just kind of change that symbol in the front. So this becomes a positive 12, which we can combine with that 15 in front. So 15 plus 12 makes our 27 right here, minus the 24i from the middle. So this is kind of the weird thing that's always going to happen to us. When we get that I squared, we change our sign because it's really just a -1. And then that is going to combine with the other constant that we have. So here I'm just going to do a little distribution and multiply. It's the same idea if I had 7x times -14x. 7 times the 14 is going to give me, what's that, -98. And I times I is I squared. Well, our I squared, we're going to cancel that and just change our sign in front because it's really -98 times -1. And that just cancels that and makes it positive 98. So that's our trick. I times I becomes I squared, and I squared equals -1. So here, example number 4, we're going to have to do some box method with this because I doubt Any of us remember that pattern involving the square of the binomial? So we got 3 plus 2i, 3 plus 2i. 3 times 3 is going to make 9. We get 6i here, 6i there, and 2 times 2 is 4i squared. So putting things together, 6i and 6i is going to make 12i, and then our 4i squared. But no, we're not done. We're never really done. I squared is going to change this to be a negative, so we really got 9 plus 12i minus 4, and that's how we get rid of that I squared. So now we can do 9 minus the 4 and get 5 plus 12i as our final answer. These things should always have just two things going on, our normal constant number and then our number with the I stuck on the back. Here we've got our sum and difference pattern. Might think this looks a little bit like the conjugate thing we were talking about before. It is, and this is what we're going to be using here in a minute. If we set up our box method, what's going to happen with our sum and difference pattern? Well, our two middle things cancel out and equal 0, right? So all we have is the front thing and the back thing. Well, that's what we're going to do. 4 times 4 makes 16. 6i and 6i is going to make minus. Oh, goodness. I just got myself all confused there. 6i times 6i is minus 36i squared. I apologize. So, are we done? No. I squared is going to change that to a 16 plus 36, which gives us our 52. So the thing to note here, if we're multiplying two conjugates together with our I, the i's are going to cancel out and just turn it down into one normal number. This is going to be very important here in about 30 seconds. Give example 6 a try, see if you can multiply, use your box method if you need to, do what you need to do, get example 6 taken care of. Alright, our complex conjugate, it's just our conjugate except we're going to have our I on the back. It's what we just looked like in the last example I did for you. So what's going to happen? Well, we need our complex conjugate because nobody likes an I on the bottom of a fraction. Just like yesterday, like 3 over square root of 5, how we've been doing that the last couple days and getting this out from the bottom of our fraction, we need to do the same thing with our I. Well, with our square root, we multiply by the same thing. With our I, we don't multiply by the same, but we multiply by the conjugate. The reason being is that my 1 minus 2i and 1 plus 2i are going to cancel the I out and leave a normal number. So my top becomes amazingly fun. Probably going to do some box method with that. You're going to get these terms here. 6i and 5i together are going to combine and make that 11i. What's going to happen here? Well, I squared makes that positive 10 into a negative 10. Same thing on the bottom. My I squared here is going to make that into a plus 4. And what happened to the bottom of my fraction? Well, 1 plus 4 becomes 5. And now I don't have I on the bottom of my fraction anymore. Here, 3 minus 10 gives us that negative 7 right here. And with our answers, we never want to leave it as one big fraction. We got to split it up. So negative 7 over 5 is one fraction, and 11 over 5 is the second fraction. And we leave that alone with our I stuck on the back. If I could reduce the 7 over 5, I surely would. But in this case, it doesn't, so we're going to leave it alone. So let's take a look at this one. I'm going to multiply by my conjugate of the bottom, that's 7 plus 3i. 7 plus 3i on the top. Well, this one, since my top is just a 6, I can kind of just distribute that. Think about what that's going to give me here. Well, 6 times 7. It's going to leave me with that, what's that, 42. And 6 times 3i is going to give me positive 18i. Now my bottom, 7 times 7 is 49. And then my minus 3i times positive 3i gives me minus 9i squared. So here's where I am right now. The reason we do this on the bottom is because what happens right here? Well, my I squared is going to change this to positive. I'm going to have 42 plus 18i all over 49 plus 9 now. 49 plus 9 is going to make me, what, 58? Now we would be done, but we're not, because we're never really done. We're going to split that into our two fractions. 42 over 58 plus 18 over 58 with my I stuck on the end. Now in this case they're both even on both my fractions, so I'm going to simplify as much as I can and get 21, dividing that by 2, divide my bottom by 2, I get 29 plus 18 over 58, I see a 2 involved there as well, 9 over 29i. And that becomes our final ugly, ugly answer. 21 over 29 plus 9 over 29i. Alright, last one I'm going to look at with you guys here. Again, we need to multiply by our conjugate. What's that conjugate going to be? But 9 plus 4i. Now my bottom becomes the easy one here. 9 times 9 is 81, and 4 times 4 gives me 16i squared. The top is going to be my tricky part, and I'm going to do a little box method off to the side. 6 plus 5i, 9 plus 4i. I'm sure at this point you're thinking, oh my goodness, I am never going to be able to do all this. You will. So I'm going to fill this box in here real quick. Bam. Alright, so multiplying all through here, this is what I've got. So that's going to leave me with 54. 45 and 24 is going to add up to what, 69. And then my 20i squared. So let's think about what's that I doing. I squared changes this to minus. So 54 minus 20 leaves me with 34 plus 69i, and that's what's going to go over here. Now same thing's going to happen on the bottom of my fraction. I got that I squared. It's going to change my sign here. So I've got 81 plus my 16. That changes my fraction now to be 34 plus 69i all over. 81 plus 16 is what, 97? Oh, that's disgusting. Well, we ain't done yet. We still need to split our stuff up. So split my fraction. 34 over 97 plus 69 over 97i. Off the top of my head, I can't think of anything simplifying into this mess. 3 doesn't go in. Yeah, I'm going to circle it and be done. I can't deal with it anymore. And I'm sure you can't either. Alright. So example 9, example 10, that's all we got left. Really, really hope you give these a try here. 3 minus 5i, 3 minus 5i. Do some box method. Figure out what you're going to have on top. Your bottom's your nice easy squares. And then take care and split it. So go ahead and give example 9, example 10 a try. You can't figure out what you're doing wrong until you try it on your own just a little bit. And I'm sure tomorrow in class we'll take a look at them as a group here. Alright, thank you guys, and we'll see you in class.